Nobody asked for another podcast, so here you go. This is yet another Infra podcast.
Hi, everyone, and welcome to our 14th episode of yet another Infra podcast. I'm your host, Vitaly Gordon, co-founder and CEO of Ferris AI. We are joined today by Diego Oppenheimer, partner at Factory AI, Yevgeny Pats, CEO at CloudQuery, and Alex Clemmer, CEO at Moment.dev. We'll be discussing today MLOps for large language models and how different it is than traditional ML models, why open source is the best way to build ETL company, and the most recent Google post about the moats in AI. Hope you enjoy. Diego, thank you for joining us. So you were the founder of your own ML infra company, sold it to Data Robot, and now doing a bunch of interesting new things. Could you talk about whether ML infra need to be completely reimagined from scratch in this new world of large language models, or is just small adaptations about maybe using more GPUs, maybe the models became larger, etc.? Kind of what is the future of ML operations?
A little bit of a loaded question, but yeah, so I think if you look at the general MLOps process, there's pieces that feel are going to stay the same. There's places that we're already seeing kind of new components, a new tool, being developed. And then there's ones that I feel like are in need of completely reimagining. So if you think about what MLOps is and what really it encompasses, it's really like the automation, similar to borrowing from DevOps. It's like the automation to getting to faster, better, higher quality kind of machine learning throughput pipelines. And so a lot of it is really software engineering work and how scale, be reliable, be fault tolerant, right? So it's really about it. And there's multiple tools in that tool chain. So if you start left to right, I'd argue where we look at the data part, which is the data labeling, how do you prepare the data? It's interesting because those components are very important still, except that we're going for quality over quantity now a lot more in the world of these kind of foundational models. So outside of like when you train these models for the first time where you're using these large corpuses, any data process beyond that is really about what I call like surgical data sets to get to a specific thing. So a lot of the tooling that exists in that space, which initially was like, how do we just get the most labeled potential inputs as possible? Now it's a lot more about kind of precision, but that's on the kind of the data side. So a lot of the kind of software and tooling that existed there, in my opinion, specializing more in like those precision data sets. So then you go into what I would call like the kind of training aspect of the models, and you have the original training of these kind of foundational models, and that's really been changed upside down. I think the original tooling around that we existed, these workbenches that existed for kind of training traditional models, really break down when trying to train these foundational models. You need new processes, you need the distribution over GPUs is much larger. These are much more expensive runs. The hardware you're using has to be, if you want to get any sort of result, is different. So I think the training side of the world has really been affected by this, and new tooling is coming out or custom tooling around it. The experimentation side of things, which I put in that middle, for the most part stays unchanged. So a lot of the experimentation tools really adapt to this new workflow. And again, like I don't think all AI and ML is around foundational models. There's still a ton of stuff that's being done with structured data, and that is important and continues. I think we're really talking in this specific world about the new MLOps in the foundational model world. The really interesting, this is where I spent most of my time looking at, was like the inference side of things. And inference is really interesting because I think you have to change a lot, right? So now we have much larger models. They don't fit on the commercial GPUs. You can't even get GPUs in some cases. You adapting these models to run there, the latency is really not good. The inference speeds are really not good. So the whole world of inference needs to be like rethought, in my opinion. And we see already old/new players replatforming, and as well as seeing completely new players with new programming languages coming in and saying, hey, we have a way of addressing this inference problem. And then you have the monitoring world, where I would look at that perspective and say they are adopting quite quickly into this world. It's somewhat different in monitoring, but at the end of the day, like those tools can adapt pretty quickly. So that's like the traditional players. Now we have the new kind of players inside that, which is where the fine-tuning libraries are coming in and the fine-tuning models are coming in, the new kinds of databases. We obviously know that the large language models work a lot with embeddings, and so you have these vector databases that are very good for that. And so we have a couple of new components that are coming into that kind of new MLOps process. That's like how I see the world of where the old needs to adapt to the new or really be invented. And there's like new components that now exist in that tooling.
Thank you for the overview. And you mentioned at the end of your answer the new players that kind of coming in, for example, vector databases. And it seems like, at least with the recent funding announcements of these vector databases, that these companies by themselves seem to be larger than an entire kind of MLOps player a couple of years ago. So my question is, do you think we'll continue seeing really an end-to-end MLOps platform, or because now the stakes are so large and there's maybe so much investment in the area, it will actually break into kind of this best breed of players? We'll have like the best vector database, we'll have maybe the best inference server and things like that.
Yeah. So personally, I've never really believed in one player, one platform to rule them all. Like, since even in traditional world, when I go look at I take inspiration from the world of software development. And I think like literally the only time where there's ever been in history, like a potential for one kind of player to quote unquote rule them all was like in the 1990s with .NET. Like Microsoft almost had the full developer stack, right? Up and down, almost had it. Almost. And that's currently the only time that like in history to my lab. And again, I might be proven wrong, but like I've looked at this for a while. So I take that in, I believe that the world of MLOps and machine learning is just software engineering to a certain degree. And we are getting more and more close of these two merging. So my thought process has always been that we are going to in best of breed by component players. And there's always going to be like kind of horizontal platforms that do a lot of these places, and the typical 5 miles wide, 1 inch deep like platforms. And that's fine. And they serve a purpose. But I think that I'm much more on the side of individual best of breed players. Now, that's not a comment on specifically, do I think like vector databases should be like funded to like more than the entire everything else? I don't know. I think like a lot of these trends are just like markets driven emotionally and by like how things are thinking about it. And I don't make a ton of comment on that, on what those valuations mean or why they were done. But I do believe in the best of breed per component side of things.
Awesome. Alex, I would love to hear your thoughts on the topic as well.
So I think one thing that's interesting about doing machine learning at scale is that I have empirically found that machine learning infrastructure decisions can't be fully decoupled from either the application or the machine learning models themselves. And so at large companies like Microsoft, you'll often have these bridge teams that speak both infrastructure and to the application teams that sit on top of them. And the reason why this affects go-to-market is because if you're developing like old Bayesian models, for example, like the consistency model actually really matters when you're doing, like when you're updating the weights and stuff like that. So I don't think that has changed, and I don't think that's likely to change. I think that the use case you have for the models is going to be intricately tied to the actual infrastructure that you use to run it. And my conclusion from this is that the extent to which we centralize on best of breed players is going to very much depend on which use cases become more uniform across the industry. So if we expect that a reasonably small set of deployments of like large language models are going to be a mass market offering that is very successful, then I would expect like a lot of the industry to centralize on that infrastructure. If you end up with this very long tail of applications that are not as uniform, my guess is that the infrastructure is also going to be less uniform. And I don't think anybody knows the answer to that right now. I think we're still in the phase where 1,000 flowers are blooming, and some of those are not going to work out, but I don't think we actually know what the space is going to look like in 10 years.
Awesome. Yevgeny, thank you for also joining us into this conversation. I would love to hear your thoughts on this.
Yeah, thanks, Vitaly. Yeah, so I'll be happy, like maybe to like both to ask a question, and yeah, I also totally in with like best of breed, especially in the early days, especially in infrastructure, especially in big areas where like you need a lot of smart people focusing on one thing and not on everything. But I wanted to ask a question, Diego. What do you think around open source, and like what things will be open source related in the AI ops area, what not, especially because it's kind of foundational things and infra related? Asking this as open source founder more in the data area, but yeah, we'll be happy also to hear what do you think where you will see more open source we're not.
So one thing I'll clarify, because I think sometimes the terms get mixed. I think when most people refer to AI ops, it's really AI applied to DevOps. So I just want to, I think that, and while I usually think of ML ops as when you're doing ops for machine learning, right? And I think some of those terms get mixed a lot. This is just me like dividing them up. In terms of the question around open source, I think in general, right? I think that developers driven anything tends to drive to open source, right? And there's a lot of good reasons for it, right? Developers are tinkerers. They want to grab something, they want to use it, they want to build it, they want to be able to test it out. And this has nothing to do with the technology, but much more with the adoption process and the development and building businesses around it, where you end up having to have some sort of open core, open source, like source component, or even a free trial to enable it. So I think that's like a must of growing any of these tools. I think some tools traditionally tend to must have open source more. And I'm not a database expert, but it seems that building a database without a open source component is just not, I don't know of many examples, right? That doesn't that have really been adopted at scale. I think when you look at other components like large training runs, it almost, the components that are easily testable and like those tend to go more open source, and things that require a lot more infrastructure and build out have a little bit more affordability. In terms of open source in general, I think we're seeing one of the most amazing open source moments in history of software, right? Like between the data sets, the models, the weights being like things. So this idea that people will be able to, and Alex Ratner from Snorkel talks about GPTU, that you can actually go train your own GPT models with your data privately. That is all being driven by open source, and an open source speed of development that I've never observed in my career. Just looking at like the speed at which these projects are moving, the speed of releases that are happening, it's really one of these most incredible moments. Like, it's hard not to be excited and hard to bet against it. I think seems like open source is truly having its kind of amazing moment here in AI.
So actually, in the spirit of providing some other things, I'm actually curious. So Diego, you mentioned that databases are mostly open source, but if you actually look at in terms of revenue, you probably would argue that, I know, 90% of the revenue, I think, in this category is like Snowflake and BigQuery and Redshift, right? Which are, none of them are open source. But also, since you kind of work, when you ran your own company, you work with large organizations, and then you also sold your company to Data Robot, which is also known with working in large organization. I wonder about just how much of our kind of this open source maxi and best of breed maximalism is driven by all of us being thinkers and developers, when in reality, will an insurance company buy a vector database, or they'll just buy something that completely abstracts all of these best of breed components away? But maybe it's not fully an app. It will still be some sort of a platform that they can extend that on proprietary data. But do you really think that more of the companies outside of Silicon Valley, outside of, let's say, tech hubs like Seattle and maybe New York, will build their own best of breed MLOps stack?
I can speak from my experience. Algorithmia was a deployment, inference, scale out kind of management platform. So think of it as everything that happens once you have a serialized model. So that's like what we built. By definition, there was other components, right? Because otherwise you don't have a pipeline. Conversation for a different day. But when I look at it from that perspective, and most of our customers were Fortune 500s. And they used in a lot of cases, it's actually like for us to even get them to use us, they had experimented with some open source components and they wanted to see it. And so it really is, when you start thinking about, I think there's like the wanting to adopt and tinker and get in the door and start using a component as an open source perspective was still really important, even in those organizations. The question then becomes around support and warranties and these like enterprise features, which a lot of the open source components also offer, right? That's their enterprise editions. That's why I said like open core. And that I saw tons of, right? They're using a lot of the kind of different databases, the different components. I think the world of data science and machine learning, having been so Python oriented, also drove a lot of kind of comfort with open source. at some point you need to make a calculation on what's my TCO of this. And like when you need to do everything with the open source, your total cost is going to be higher than having a company that's going to support it and do like the infra and training and all that stuff. And so those companies, while still adopt open source, they want the enterprise version of whatever. And that's like where I saw a lot of right now. And to be clear, we did not have an open source component. Like we never did, right? We had a bunch of kind of things on the outside. I never went with an open source component because I didn't really know how to monetize an inference platform through open source. But that's just because Diego couldn't figure it out, not because you can't do it.
So I think your question, Vitaly, is really interesting. It reminds me a little bit of the original industrial revolution, where originally when people made factories, they had these sort of large machines that sat in the center of a warehouse, and then they'd attach belts to all of the other machines that needed to be run. And they were super dangerous and super inefficient because energy transfer becomes less efficient as the belt gets longer. And then electric motors came along, and you could go back and retrofit all of these factories and get 10 to 20% efficiency changes. But for most of the companies, most of the textile factories, those sorts of places that use these motors, it wasn't always worth it to actually go do the retrofitting. But what did happen is that the electricity allowed people like decouple where the motors actually sat inside the factories, and it allowed people to build new kinds of factories. So in particular, it allowed for assembly line style factories where you could have specialized labor assembling parts of the car or something like that. I don't know that I have a lot of hope personally that we're going to like retrofit all of the places where you could put like large language models like customer support. My guess is customer support will continue to be somewhat manual. Maybe we'll have like reductions in force, but my guess is that consumption over the long term will change the way that businesses operate in a somewhat fundamental way. And that we don't know how that happens yet, but I think that people will start to restructure when it becomes trivial to do stuff like text synthesis. I don't think that'll be like tomorrow. I think that's like a multi-decade thing. But you're right that probably insurance company of Omaha or whatever is not going to be like, we're going to adopt a language model and it's going to do all claims or something like that. That's not, I don't think anybody is assuming that we're going to have like them adopting vector bases and doing that kind of stuff.
Awesome. So let's continue on the topic of open source. Yevgeny, you're the founder of Cloud Query, an open source high-performance data integration platform that is built for developers. So historically, most ETL companies have been proprietary, and I think still you might argue that the vast majority of the revenue is with companies like Informatica or Fivetran. But you have a strong opinion on why this is the wrong way to build these companies, and actually open source is the only way that an ETL company can succeed in the future. Can you tell us more about that?
Sure. So yeah, I would say it's not the wrong way. I think it was a good way, but now I think there is a more efficient, cheaper way. And maybe I'll start with, as you said, like Fivetran, or like what Fivetran did really well, or how they started, like where the revenue, most of the revenue is. So they started with a small set of connectors, which like whatever they did the research, which are used by a lot of companies. I think like specifically started with Salesforce connector, and probably is like most of where their revenue is today. So they put a lot of people on that connector, on building it, on maintaining it, like maintaining that connector, and then giving it also as a service, right? Also running the compute and the storage for you. So that's a lot of value right there. And you can have a lot of customers that basically you have enough revenue so you can develop one connector, maintain and give it as a service, and also sell it to enough customers. But then they started also to develop more connectors. And this is like where kind of the problem in ETL space starts, right? So in a lot of companies, you have data engineers. A lot of the code is proprietary. A lot of the code is you write your ETL code over and over again, right? And you're looking for that product that can do that for you, or someone maybe already did it. So you have more and more companies like building more of those connectors, and some of them like high growth as well. But then the problem there is like a business and technical problem. To develop a connector, actually the cost is not the initial building. So you can build those connectors pretty quickly, and then you can say on the website, hey, I'm supporting the connectors in the world. and then everyone are coming for you. Then everyone are starting like to ask, okay, can you have this change, or like this API changed, like API changes, can you update this connector to the newest API? And this is like where the real cost of development is, the maintenance. And then you actually can't keep up because like, you have thousands of connectors and you don't have enough people and you don't have like enough customers to support that, because not every connector has the same usage as Salesforce connectors, right? So some connectors can have few customers, and it will be like hard to have enough engineers to maintain it. So the way I think to solve it is around open source, right? So you can like to build an open source framework for ETL for developers, and this is what we do in Cloud Query, to give users and the community, to give developers, to give vendors themselves ETL plugins and maintain them, right? Because I think that's like you have to turn this upside down, maybe a bit similar to like how Terraform did it in the infrastructure space, right? Terraform maintains AWS, GCP, Azure, right? The big plugins that are used like by 80% of the companies probably, but then they have thousands of connectors that are maintained by the community, or sometimes even maintained by the official vendor, which is actually a great way because the vendor maintains their APIs, the vendor maintain also the Terraform connectors. So interest kind of aligns of also having the quality of those connectors aligned with your API. But to do that, you need an open source framework, right? Because without open source framework, developers can't develop on top. If it's closed source, it's a hard technical pre-requirement. Yeah.
So I have a question about your journey, actually. As I recall, maybe this is not correct. Originally, Cloud Query was like an open, like OS query, but for cloud resources, essentially. And I'm curious to hear a little bit about how you ended up here in the more generalized ETL space.
You recall correctly. So I started actually that project just to solve one use case. I actually just wanted to get data out of AWS and GCP to and Azure to Postgres database. That was like the first sources and the destinations. So I released it, and people like started using it. Some big companies as well, and we continued working on that. But then as we started developing that, we really quickly look at, okay, what we develop, right? So always when I develop something, I always think in terms of abstraction layer, and okay, what is this thing that I'm building, right? Especially in open source, like what is the fundamental underlying framework, right? That does it exist, or if not, what is it I'm building? And we saw, okay, like we are building an ETL engine, right? Yes, US and GCP and Azure source plugin doesn't exist in Fivetran or Airbyte, at least not that, I don't know if they exist now when we started it, but it is what it like. This is exactly that. So the only way like we thought we can win it is if we build that framework, right? Because if we just focused on AWS, then I don't think that will be like sustainable, because then like at least our bet was there will be a framework, right? An underlying framework that will solve as plugins, right? GCP plugins will have also all the other plugins. So if we want to win here and play the long game, we have to build that framework. Yes, our first plugins, our first use cases will be around the infrastructure because that's where we started. But yeah, if we want to like win and have a sustainable like business and usage, we need to be that company that also build like that foundational layer, right? Because otherwise we'll be easily replaceable, or like that at least was like the thinking and the bet.
So it sounds like there's some magic in the initial audience that you're choosing. You talk about infrastructure engineers and developers specifically. It sounds like basically what you're saying is that you are targeting a specific audience because you're targeting developers and infrastructure people because they are central to a lot of processes, and by empowering them to be able to do their jobs, it allows you to expand outwards from what is originally like a fairly humble use case, which is just like syncing your AWS data and your Azure data to a database somewhere.
Yeah, so I think the initial use case is like a bit accidental, right? So I started with that use case, and it turned out to be use case with like relatively like good amount of usage and companies using it. But I think the important thing, if we started with a different connector, it doesn't matter what it is, it's like Salesforce or something else that also got us traction, it would be good enough, right? So basically the game for us as an open source project is we want to build the underlying framework, but for an underlying framework, it's very hard to drive adoption without use cases, right? So you'd have to do two things in parallel. You have to build the underlying framework, and you have to build some strong use cases, which are like specific because you're a small team. And then you have to drive that adoption to drive more and more users. And once you have enough users, you go the managed version, so you can also have revenue, right? So that's, you have to play that game to eventually to have enough revenue and then grow the business, grow to different connectors, or grow to have more features. But you have to stay as lean as possible on one hand, but on the other, also find enough usage to drive adoption to your framework. So also people start building like their connectors, right? And have that critical mass of users.
So I want to also discuss another aspect of open source that I think is actually not as well understood. I think everyone gets why open source is great for developer adoption at very tech companies. But I was surprised to learn that kind of large companies also love open source, and pretty much large banks and Fortune 500 companies all kind of use open source, and not because it's free or cheap. They always actually push the open source vendor to provide them with more support, and they are more than willing to pay for it. But they actually see in open source some sort of protection against a vendor lock-in. And Diego, as someone who spent a large portion of your career working with these customers, can you tell us more about the kind of how large companies look at open source?
Yeah, so I think it's the in the same way that people talk about like multi-cloud hedges because you don't want to be locked in. I'm not convinced that that's not just the party line, to be honest, because I think what people find later on is that actually trying to develop. So like this is a public use case, but like Capital One went all in on AWS and stuff like that. And then when closed doors, you kind of ask and say, okay, was that like, what were you worried about and the risk of going? And obviously today they use other clouds, but if we were going to go from on-prem to a cloud world, are we really going to go teach 5,000 developers, 10,000 developers, whatever they had, 3 clouds at the same time? Just figuring out one is hard. And so that's actually one of the real aspects of that kind of like multi-cloud world. Now, translating it to the open source software, like I think there's a little bit of that there as well, which is, yes, there is I think open source helps when adopting technologies from a startup, because if the startup goes away in some way, shape, or form, like their offboarding process, which is really a lot longer, it helps. It also helps with, if you think about most enterprise vendors end up with, let's say you do 2 releases a year, 4 releases a year, whatever, but you have to support that release for at least 3 years. And so they're actually caring a lot more about, they understand that updating software and moving from versions to software takes them way longer than anybody wants to admit. And that the open source component also gives them a little bit of safety in terms of, if we're adopting this thing, like we can go at our own pace. I personally think the biggest driver, the real reason and driver ultimately is they have a ton of legacy systems. And at some point, open source component gives them the ability to still connect their legacy systems instead of moving to kind of like more modern stacks. So it gives them a flexibility on adoption. And because the amount of super old systems that I had to end up integrating with, which you would never even considered, and like you'd say, no, I don't want to integrate into that system. And they're like, we're just going to we'll add another 0. And now it's interesting, right? And you end up doing all that. And so I think the truth is, it's partially what you said, Vitaly. That is true. I think around the block, but I think the real driver ends up being most of these tools are in an ecosystem, and that ecosystem in a lot of these companies is extremely old. And to be able to continue expanding and developing and connectors and all that stuff, an open source component gives them a little bit more flexibility.
Yeah, I think I'll also be happy to weigh in on that. Yeah, we have some of our first customers actually were like very large enterprise financial institutions. And I think like some of the things that we saw, like why they went for open source is like one thing, it gives them a way to try it out before you buy. And usually those companies, as you said, like the offboarding process is long, the onboarding process is also long. So it gives them a way to try it out at their own pace, like without paying upfront, because it's also hard to know what will work for you right away, like in a 2-week demo or in a month's demo. So you want to, like, they want, let's try it like for whatever, 6 months, 8 months. If it works, great. Like we'll call a vendor, ask them for support, but it's easier like to just try it out. And also it gives them the ability to, the other thing, to try it out without paying also, and being able also to push, let's say something is missing or they need a small fee for that trial, they can commit and to a fork or just commit back to upstream and try it out without like right away paying for multi-year deal, very expensive deal before the trial period, just because of those companies, you need that time. So open source give that flexibility. That's what we had with some of our initial customers that were like running it for quite a while, committing upstream, making sure it's working for them, it scales. And the other thing, I think also a lot of those big customers were also burned by some, not to say that all vendors are like that, or like if vendor is not open source, it's not good, but they were burned, I think, but also a lot of like bad vendor behavior sometimes, where the vendor is selling, like marketing something that is not real, and it's not, there is like lack of transparency. So they end up like paying millions of dollars for something that would work better as an open source, or that vendor just sold them like exact open source version without anything on top for like too much money. So they like always check is there an open source version? Can we start with that and like then expand? Because once you get something to an enterprise, it will be very costly to get rid of that. So you want to be like as sure as possible.
Yeah, so I think I'll go and kind of add a little bit of a history lesson for some of our listeners that maybe don't remember the days like before SaaS. And one of the things about SaaS that I think was misunderstood, and I actually truly got it when I started working at Salesforce, was not that SaaS created a better product experience so everyone bought it or any kind of that kind of stuff. It's really pre-SaaS, a company could buy 3 software solutions in a year, right? Because for every single software that was sent on CDs, there had to be an IT team that would need to go buy servers, install it, maintain it. And basically, you only bought like the very largest categories of software, whether it was an ERP or maybe a CRM, but there was just, you would never get an IT team to implement some kind of tactical solution that you need for a marketing team to, improve the way they write emails. It would just never rise to the level where an IT team would care about it or have the capacity to actually implement such a system internally. And I think to a degree, those IT teams now have been replaced by security and compliance teams that in order for you to engage with vendor in some of these larger companies, you need to go for 6 months of vetting and kind of all that. And that is actually one of the things that stops from many companies just succeeding, is like, it's just not worthwhile to go through that very kind of lengthy just evaluation cycle. And I think one of the things that open source does well is, while technically most of these companies that will tell you that you need to have the open source vendor go through a similar process, no one is really doing it. They just open their laptops, install some software, play with it, and then if this is interesting, they move to the next topic. But actually, Alex, continuing on the open source topic, a couple of days ago, a letter from Google stating that Google doesn't have any AI bots, nor does OpenAI. That offer also continued to say, that letter was leaked, and the offer continued to say that open source model will eventually win this battle, as having many small groups around the world iterating on small models will be far more efficient than just having a handful of large organizations iterating on these like very large models. And that path will win, and Google should start doing something about it. I'd love to hear your thoughts on the letter and that topic.
Okay, yeah. So let's go through the timeline. So the timeline that the offer, I'll give my commentary after I go through like the specific timeline that this author is referring to. So February 24th, right? Like Llama. This is released by Meta. The code is open source, but not the weights. Next week, Llama's weights leak. The next week after that, Artem Andreyenko gets it working on a Raspberry Pi, but it's too slow to be practical. The next day after that, Stanford releases Alpaca. The next day after that, Eric Wang releases Alpaca Laura, which is like a low rank fine tuning thing, which allows you to do the training on a single RTX 4090, which is a somewhat affordable graphics card. 5 days after that, Georgy Gerganov uses 4-bit quantization to allow us to run Llama on a single MacBook CPU with no GPU, but a ton of RAM. The next day after that, 13 billion Vicuna gets released, and GPT, and it costs $300 to train, and 6 days after that, Namek releases GPT for all, and it allows you to, it collects all of the models in one place. They're trying to create like an ecosystem out of that. A few days after that, Cerebras is released, and it is entirely open source. So people are no longer dependent on Llama. It's compute optimal, apparently, at least if you buy the Chinchilla paper results. A couple days after that, people can achieve state-of-the-art performance on multimodal science QA because of in 1 hour of training, because of parameter efficient fine tuning. Only a couple more. Real humans can't tell a difference between ChatGPT and Koala a couple of days after that, and it costs $100 to train. And then open source RLHF reaches ChatGPT levels, right? So the author is referring to this period of a month where all this insane shit happened. And it's interesting. I think it's really interesting that the title of the article is like, Google doesn't have a moat. It seems to me that the timeline makes the exact opposite claim, which is that Google definitely does have a moat. It just takes all of the machine learning world working together all at once on the same problem to displace it. And I think that should be worrying to Google, but it does seem to me that there are, like, in a normal functioning world where there's not this incredible ecosystem of people and all of this excitement to try and innovate, I do think that this would be a pretty defensible moat, because it takes a very long time and a lot of energy and a lot of time and a lot of resources to actually do all of this stuff. What I think the author means to say is that Google is doing a bunch of the foundational work and is capturing essentially none of the value, and is not on track to capture any of the value if things continue going this way. And that may be right. That probably is right. And I think that implies a different sort of go to market, to the extent that they are going to market with this stuff, than what they're actually doing. So yeah, I'd love to hear what Diego thinks is like the actual practitioner in the room.
I think it's interesting, because I think this is a reaction. So first of all, I don't know if we know if it's a real leak or not. I think there's questions about that, kind of irrelevant. Let's just assume that it is real, and I think it makes a ton of sense. 2 months ago, whatever, we were talking about why even bother, maybe not, but a little bit more. You gave the proper timeline. Let's call it 3 months ago. Why even bother? Like, there's going to be 3 model providers in the world, and it's going to be like one model to rule them all. And the speed at which that was dispelled, right? In terms of like in real time, like we saw it like unfold in real time. And obviously, I'm sure there was people who were like believers of it for a while, and there was like a couple labs that were talking about this, and there was a couple articles that came out a while ago about this. But I think the thing here is that the models themselves were not the moat, right? And they were going to be, new tools were going to come out. There's this space of fine tuning that is unexplored in terms of how far it can be pushed, right? And if you think about how far that can be pushed, then starting from these open source models and like really pushing forward on the fine tuning world, like you might get for specific use cases, like state of the art quality for that. Again, you don't need state of the art quality for everything. So as you start breaking down and you look at the long tail of these models, like if I'm doing SQL transforms, why do I care if it can give me the best recipe for French bread now in some other language? And so like we start looking at how that long tail of models starts becoming a lot more interesting from actual usage in real world. And around, when you look at the adoption of these LLMs, I look at 3 things, right? Which is unit economics, the latency, and the data that you need to make them really contextual, right? And how private that data needs to be. And so when you think about that, like there's real advantages to push forward on the smaller, more specialized and open source models that get you there. And so that's where I see there's a big trend towards that, right? And it's really about fit for purpose. And so there's a real economic driver that is powering this. So I think like I think the bet here, or what I read in between the lines, was just having one supermodel wasn't going, or series of supermodels wasn't going to be, that's not the moat, right? It's really about like, how do you can actually provide these applications? So that's kind of like where my head's at with this kind of like leak and stuff like that. I think it was maybe a little bit more obvious that it wasn't going to be like one provider to rule them all.
I feel like we did know that though, right? Upstarts have been undercutting the large providers for a very long time, like Stable Diffusion originally, but not even the original one, but Stable Diffusion being one example, a company with vastly fewer resources than either of the major incumbents, just totally undercutting people on a very specific use case, or like to some extent Midjourney is like this. I don't think the debate was ever, is the model the moat? Like the answer is clearly no, and has been clearly no for a year, in my view. I think the interesting thing about this article is like, it's like we have no moat, but I keep coming back to, I just don't think that's actually true. I think what the author is actually saying is that the moat is whoever is able to iterate on this stuff at all, or at all quickly. And Google and Meta and OpenAI actually do have a pretty good moat because it's pretty hard to build that stuff. It's just that the rest of the world happens to be concentrated on that exact problem literally right now. And when all of those people are concentrated on that problem, it's very hard to be competitive with all of those resources, because even these nation state sized companies, like they have finite numbers of resources. So my guess is, I think in a sane world, that would probably be, that is, I think Google's original moat as well as a business. Like you think about, why did Google succeed versus like Excite or like Yahoo or whatever? My personal view is that I think it's because they viewed infrastructure as a fundamental competitive advantage in a way that the other search engines did not. And so they started spinning that flywheel. And now it's like they are the most efficient search engine by many orders of magnitude, probably like 1,000x. And there's no way to catch up without pouring tons of resources into it. And that's why Bing is Bing and Google is Google, as a person who worked on Bing. In a world where the market was behaving sane and like people weren't acting like crazy people, like I actually think that they probably would have done a pretty good job, right? Like they probably would have been able to build similar infrastructure, and they probably would have made it possible for they would have lowered the cost of training these models and doing inference and all this stuff. They have been doing that with like TPUs. They've been doing this for decades. And eventually, like they would have spun that flywheel for long enough that it would have been very hard to displace them. It's just that as it happens, all of this stuff is happening all at once, and they do not have the luxury of time to develop this stuff, and they're competing with the rest of the planet. And I do think that core point that the article is making is actually true. And I think that my guess is that that will continue to be true.
But
yeah, go ahead. Yeah.
Sorry. Yeah. Let me put it back, because just several episodes ago on this very podcast, we were having a discussion about basically equating what is happening now in the foundation models world to the Moore's law and the kind of development of custom silicon that actually never happened. We still basically have 3 companies maybe that are developing silicon, which is basically Intel, NVIDIA, AMD, maybe, right? And every single almost attempt at developing a custom silicon was not successful. And there were very smart people that started arguing that this might be the case with foundational model as well. So maybe what we learn from that experience is the world of atoms is very different than the world of bits. And maybe in bits, yeah, it's actually let flowers bloom, and there are no kind of such modes scale. But in the world of atoms, like whether it's CPUs, GPUs, or maybe even in kind of the large cloud providers where you need a large amounts of capital just to buy hardware, maybe we actually see that the foundational models is more about the code rather than how many GPUs you can buy.
Yeah, totally. Another way of thinking about this is like none of the stuff that we interact with day to day exists, right? Like functions don't exist on computers, right? Like classes are not a thing. but we build these abstractions, like knowledge workers build these abstractions so that we can get the computers to do increasingly complicated things. That's why we build all of this artifice out. And I think what that implies is that if you're shipping software, like you're shipping all of these you're shipping all these things in terms of abstractions. And the point of doing that is because when you're doing something like that, the thing that really matters is delivery and distribution. So the faster that you can ship that stuff to people, the higher fidelity, the more that you can learn from it, the better off, like all things equal, that you're going to be. And I think that was like even the lesson of the personal computer revolution is back in the 80s and the 70s, like people thought that hardware was the only thing and software was just like this little toy. And what they found is that the software is the thing that like sticks around, right? And like your point about the SaaS is actually super interesting, right? SaaS made it possible for people to buy more stuff, right? Like it's a fundamental change in like distribution. And I think that it is almost certainly the case that's going to be true for pretty much any revolution in software, but especially like AI, where the factors that you use to get into production quicker, the accessibility of that stuff, the more people that can actually use the technology, the more places that it's practical means that the more use cases it's going to wedge itself into more use cases. And that's when stuff gets really sticky and has a lot of staying power. The better the distribution mechanism for software, the easier it is to build this stuff. Yeah, I think you're completely right.
And with that, we are going to wrap for today. Diego, Yevgeny, Alex, thank you so much for joining us. And for all the listeners, thank you for tuning in and hope you enjoyed the episode.